And I'm at Pipestone now. I've been there now for about 3.5 years. Prior to that, I was at the University of Minnesota, where I've met many of you. I was a faculty member there for 12 years. And then prior to that, I was a swine practitioner in Morris, Minnesota. So I've been in the business for a little while. And this is a wild one. This is a new paradigm. So we'll take it from there. What I'd like to do for our time together today is go down this list of topics. I'd like to first disclose that I have no conflict of interest in any of the material that I'm going to talk about. I'm going to talk about a liquid antimicrobial product called SalCurb later on. Pipestone does not use SalCurb at this time. It does not sell SalCurb. We make no money from SalCurb. This is strictly a science presentation. But it's a wonderful product that I will share with you what we've learned. So that's a disclosure. Most of the funding for the study that I'm going to show you have either come from Kemin or it's come from Pipestone internal. So that's where the money came from to run these projects that I'll share with you. I think we'll start out with what the heck's happened to PEDv, talk a little bit about why we're seeing a different picture this winter than last winter. It's a good thing. Then I'd like to review for you some of the risk factors of PRRS virus and PEDv spread, because they're very similar, yet there's that feed wildcard that we want to distinguish. And I also want to just review for you a little bit about how the PEDv polymerase chain reaction is run and how it's read. So when we talk about CT values, we can understand what that means. So that won't take too long. Then we'll get into, I'll tell you our story from Pipestone about PEDv and feed, where we were a year ago, and what happened, and how we learned from that and tried to become better, what we did about it. And then we'll get into some information on feed biosecurity that I've learned over the last year, some things that we did very immediately, and some things which have taken more long-term planning. So hopefully you'll come away with at least one good idea from the presentation today. All right? So what a difference last year versus this year. Now, why would that be? We're debating this question a lot around the vet clinic and asking producers, and I'm curious if you see that. We'll go down this little list. This is kind of what we come up with, but maybe you've got some other ideas as well. But obviously we've got immunity in the national herd now. And there's been a study from our group conducted by Dr. Adam Shelkoff, one of our veterinarians, as well as Dr. Bob Morrison and his graduate student Dane Godey from the University of Minnesota, that shows with homologous or heterologous PED virus, immunity is solid following previous exposure, and it's long-lasting, at least out to 5, 6, 7 months, perhaps even longer, in the pregnant sow that she delivers that lactogenic immunity to the piglet. So we've got a lot of sows that were exposed, and they're delivering protection to their pigs. That's been well documented. I think biosecurity overall in the national herd really elevated. I mean, we tried to pound that home during the PRRS days, but I think the PED issues have really shown us that biosecurity of trailers, personnel movements, contaminated pigs, that's important. And I think there's been a lot of Synergize used, which is a good thing. Synergize at 1 ounce per gallon will kill this virus within a minute, which is some work we did as well. So the more we use products that are efficacious, the less viral load we'll have in the environment. So I think biosecurity of trucks and premises, pig movements, people movements, and that has extraordinarily improved, and that's helped as well. Then I think the feed, really what that did for us is raised awareness of risk. If you remember when I did the old snowball from hell work with PRRS, we put the virus in the snow and we showed how easy it was to move around, that raised the awareness of everyone that mechanical transmission of PRRS virus was possible. The feed story I'll show you raised the awareness, I think, in the national herd that feed can be a vehicle. Contaminated feed can be a vehicle for the movement of virus into farms. And I'll share our data with you why we believe that to be the case. So I think this is new information. These are new applications. And I think these in combination are important reasons why we're seeing a difference this winter versus last winter. So I don't know if you had any other ideas that may be playing a role as well. Yeah, it's kind of what everybody thinks when you ask them that question. They kind of come up with these three. Maybe lack of reporting. All right. So, with that as a background, let's just quickly go down the list of how HERS virus is spread and how PED virus is spread and compare and contrast the similarities and differences. So what you see on the far column there is different routes of spread. So genetics, people, supplies, transport, air, and feed. HERS virus that we've documented and others have documented, you can see that the majority of those routes are risk factors for HERS virus, but not feed. We did some work at Pipestone a few years ago that showed that HERS virus does not even live for an hour in feed. So feed was never on our radar for PERS. We kind of crossed it off the list. But you look at the PED list and you see that, indeed, infected animals, people, supplies, transport, air, and feed have all been presumed to be risk factors. Now, there's very few transmission studies that have really proven each of these, but there's a lot of good data from the field that would suggest that these routes can be risk factors for PED virus spread. No question the airborne route, no question transport, no question dirty boots and coveralls, no question you can get the virus on your hands, and obviously if animals are moving from place to place and they're infected, they're going to move the virus too. It's shed at such high quantities in the feces that it's almost impossible to stop. But the feed's a wild card here. So this just kind of gets us on the same page as we design our biosecurity protocols for PERS, which were very successful at Pipestone. And we thought we were doing a pretty good job with PED until things changed last January. We'll tell you that story. The other thing I just want to review, this, you probably know this already, but the PCR test, we talk about the polymerase chain reaction test for PEDV. It measures RNA, it measures genetic material. It doesn't tell us whether the virus is alive or dead. It just shows us that the genetic material of the virus is present. So it's really a semi-quantitative assay right now. There's not a real quantitative PCR. They're being generated, but right now it's more of a semi-quantitative assay. And the values that you might have heard your veterinarians talk about are reported in what's called CT, or cycle threshold. Now, as the PCR cycles, turns over and over and over again in the laboratories looking for bits of RNA, the more times it has to cycle, the less virus is present. So the higher the cycle time, for example, 38, 40, those values are basically negative. It's turned so many times that the lab has said, okay, there's no virus here. Now, if you have a low CT, say 15 to 25, that means it hasn't had to work so hard to find that bit of RNA and start to amplify it. That means there's more virus present in that sample. So it's kind of backwards. So the lower the CT, the greater the virus. Because we're going to use CT a lot today, and if you don't have that kind of in your head, it can be kind of confusing. And anytime you want to ask any questions about this, please let me know. Okay? Everybody clear on risk factors of transport and transmission for the two viruses, as well as how the PED PCR is reported, what it means? Okay, good. All right, now I always show this slide whenever I talk about feed and PED because it's a very, very touchy issue. I think it's gotten better. But early on, last year, and maybe even in the original thoughts of how the virus got into the country, feed was discussed as a potential vehicle. And people didn't like to hear that. So what our position from Pipestone really was, we're not here to fight with anybody from the feed industry. The feed industry are our partners, and we have to work together. We simply want to know what the risk is. You know, as you know, we manage sow farms for our shareholders, and our job is to keep viruses out of those sow farms. And if viruses are coming in a risk or a vehicle or some route that we don't know, we got to figure it out. It's like where's the bullets coming from? So we always, take a step back and say, this was a very emotional time early on, but let's talk science and let's talk collaborative working together, because we got to know this. That has seemed to help a lot, especially early last year when we were going forward with this discussion. All right, so let me just tell you our story at Pipestone about PED, and I want to give a lot of credit to Dr. Joel Neerum. Dr. Joel Neerum is our Director of Health and Biosecurity at Pipestone. We have 52 and growing sow farms we manage for our shareholders, and Dr. Neerum oversees the biosecurity protocol for all those sow farms. And so he's very, very detailed. And he takes data, a lot of it we generated in Minnesota on PERS, and he applies it on a large scale across the system. So when PED kind of started rolling in 2013, we immediately had 2 farms break near our eastern Iowa clinic, near Independence, Iowa. So right in May, things started hitting the fan in about April or so. May we had 2 breaks. Joel immediately removed all the animal byproducts from the rations and all the sow diets and the GDU. Because we have on-farm GDUs. GDUs come in as wean pigs and grow up as to be replacement gilts. And so all the byproducts were taken out of the GDU diets as well. And I think that did some good because we went for the rest of the year without any more breaks. We were just, no one really knew what was going on, but that was something we thought could have a benefit. And so it worked pretty well. So we were, December of 2013, we were, I think, a little cocky because we'd gone the whole year with only 2 breaks way back in May. We cleaned those up. We got it out of the farms, which is actually pretty easy to do. Sitting good until about a year ago. Kind of after the New Year's hangovers were wearing off, they started hitting us again. Because we had a very, very large rash of sow farms become infected within about a week. For example, 4 farms in one day, 7 to 8 farms within a week, all within that first week or so of January. Okay? Now these farms are interesting because they were very high biosecurity. Many of them were air filtered for PERS. They had transport sanitation, they had shower in, shower out, they had a D&D room, they had negative breeding stock suppliers. It was really well controlled, thanks to Dr. Neerum. And there were no animal byproducts in these sow feeds. But what was interesting was the epidemiology. When we looked at these farms, we started seeing a very repeatable pattern across all these farms. Primarily that clinical signs of PED began within 1 to 2 days after a feed delivery. So these farms had an emergency outage of feed in a specific population. And I'll show you some farm data to support that. But pigs needed feed. The feed came, it went into a specific bin, and those pigs that ate that feed were the first index cases on the farm. So that happened in all of these cases that we just dealt with. And it was also minus 20 to minus 30 degrees in January a year ago, if you remember. So lots of things were going on here. And when we started looking at feed, is it even possible that this is happening? We had no clue. It just was this interesting epidemiological pattern. And I started going to the literature and start to look, how can I figure this out? Because Luke Minion, our CEO, gave us the ultimatum. He said, you guys figure this out. Figure it out fast. Spend what money you need to spend, but get it figured out right away. So I went to the literature and tried to look for ways to sample feed, to look for PED in feed. Well, there's nothing there. There was no publications, so there was no starting point. So everything you'll see we did, we basically invented. Here are 3 farms that I'd like to share with you, and what this will show you is this temporal relationship of feed delivery, consumption, and clinical science. So the 3 farms are A, B, and C. These are 3,000 to 5,000 sow farms, southwest Minnesota, northwest Iowa. Well, I just want to go down the line here and just look at some specific dates. So these farms all had the feed outage that we talked about, an emergency feed outage in a specific group of animals. So the feed came to Farm A, for example, on January 6th. So the outage was on Jan 6th. The feed came immediately from the mill, and all these all this feed came from different mills, so there was not a single mill involved either. Jan 6, Jan 8, Jan 9. So that's roughly the time period we're in now. The feed was consumed by these animals very quickly, within a day or so. And the feed went to feed a specific population of animals. For example, in Farm A, it was the West Gestation room that ran out of feed, and a specific room in the GDU. Both of those populations ran out of feed. So that's where the feed deliveries went, to tanks that fed those specific populations. West Farrowing in Farm B was out of feed. North Gestation in Farm C. So they were very focused subpopulations of the herd. Now, the clinical signs, vomiting, diarrhea in sows, began, as you can see, shortly after that feed was delivered and consumed. January 9th, 3 days. January 8th to 10th, 2 days. January 9th to January 12th, 3 days. 2 to 3 days from consumption to clinical signs. Where were the index cases? The first clinical animals, right where that feed went. It went to the bin that fed these animals, West Gestation, Room 2 GDU, West Farrowing, North Gestation. And we diagnosed the disease in those subpopulations. You can see the timetable there. Then the other thing we did that I'll describe is we actually went into the bin where that feed delivery had been made. Kind of climbed up the ladder and went down with a big paint roller on a large, long pole. And what we wanted to do was, rather than just take a free catch sample of feed out of a big tonnage, it seemed to be more sensible to kind of scrape the sides of the bin and collect some of that feed material that would hung up along the sides of the bin. To me, that seemed like a more logical way to sample a big compartment than just to take a pound or 5 pounds. Chances are you'll miss it. I was worried about that. So we actually did climb up the pin and with these long poles, and I'll show you kind of some pictures of that. But look at the CTs that we found from that feed bin material, that feed that was hung up on the sides of the bin from that delivery. 20, 22, 19. Those are strong CTs. Those are very strong CTs, and as we talked earlier, that's suggestive of high loads of virus. Remember, 38 to 40 is negative, so these are getting down there. The cycle is, the PCR machine is only turning a few times before it finds this virus. Okay? So there's the story, the epidemiology, and then the interesting temporal relationship, and then the final product in the feed. So we kind of were wondering, well, if that's the case, how is this feed getting contaminated? How is virus getting into the feed? We didn't have any idea. So what we started doing was going to these farms right during acute outbreaks and taking a lot of environmental samples. So there's our paint roller on the long extended pole. We went all around these farms on the outside and just took a lot of environmental samples while inside the building there was clinical cases of PED. And what we found was, we found the virus during an acute outbreak, especially in the wintertime. Virus is everywhere outside that farm. You could find it coming out of fan exhaust on dust particles. You could find it on the ground where that exhaust air hits. We found it on all the sidewalks and any of the concrete pads around the facility. We found it on us. We weren't in the barn yet. We were just walking around. We found it on our head, hair, in our nose, shoes. It got in our vehicle cabs and on our tires as we left the farm. We even went to the feed mill and started looking at the feed and saying, well, what if feed trucks leave these contaminated premises and they bring grain to the mill? Could they bring virus along with them to the mill? Well, they certainly could. We found truck tires of feed trucks coming into the mill at the driveway that were positive. And the feed truck itself, the exterior of the feed truck itself was contaminated. And again, we found the virus or the RNA in these suspect feed bins. Okay, so we collected all this diagnostic information and showed that virus was at all of these points. And then came up with this hypothesis for what was happening to the feed, how it was getting contaminated. A farm becomes infected. Okay? Now the ground around the buildings become contaminated, which we showed. All the concrete access points on the outside of the farm become contaminated. Delivery trucks or vehicles, as they move on and off the farm, become contaminated. And if they're going to the mill, they can carry that virus in their cab, they can carry that virus in their tires right into the mill. The driveway becomes positive, the feed trucks are positive. It contaminates the mill. And at the time we spent around the mill doing this work, we started seeing a behavior pattern which was kind of interesting to me, that when a vehicle would come in and grain would get dumped into the pit below, a lot of spilled grain was getting swept back down into that pit. Well, that makes sense, but what was also getting swept down into the pit was all the debris and sludge from those trucks. And so we were wondering if there's virus falling off those trucks onto the floor and that's getting swept down into that dump pit, is that a potential way that the feed can get infected? Not an ingredient so much, but an actual environmental contamination. And that's, the batches get contaminated, they go to the farm, the cycle just repeats itself. And the more and more farms get infected in an area, the more and more nuclear the situation gets. Okay? So that was our hypothesis. And we tried to have data to back up these points. All right? So that's how we thought the process was moving on a farm, and that's how we thought those bins got contaminated through those feed deliveries. But yes, you may know many of our shareholders are quite critical thinkers, and they were saying, well, all you've really shown me is you've got RNA in these samples, especially these feed bin samples. You haven't shown me that virus is live. It could be dead. It's true. So what we did was we set up to do a Swine Bioassay. Working at South Dakota State University, we work very closely with South Dakota State. They're only a few miles from Pipestone. There are some very good scientists there, Jane Christopher Hennings and Eric Nelson. And they've got a very nice facility called a Biosafety Level 3 facility where you can safely conduct these kind of trials I'm going to tell you about. So these are done in facilities that are very well protected so that the community is not at risk. So basically what we did was we set up a very simple experiment. We took 3 groups of pigs. One we'll call the treatment group. These were 5 pigs. They were nursery pigs. They came from a negative farm. And we're going to let them eat PCR positive feed material from those bins. We're going to mix it up and give it to them. See if they get infected. Positive control group was basically, let's even see if feed transmission is possible. Let's take feed we know is negative from a separate source. Let's spike it with real virus from the lab. Actually pour it on top. And just let them eat that. Just to see if that's even possible. Maybe that doesn't even occur. So that's another room. So room 1 and 2. Then the third room is a negative control group, which is really looking at, are our methods clean? Do we have mechanical, accidental contamination from room to room just by the way we're doing our business? So that's a negative group, and the goal there is to see if they do stay negative. That's proving that our methods are clean. Now, we let the pigs eat feed via natural eating behavior. We thought that would be more realistic than, say, a gavage or some type of forced oral feeding. So as I mentioned, we did this under very controlled conditions. We had naive pigs come in from one of Dr. Kirkhart's farms that he takes care of. They were negative for PED. They were tested on arrival. We used feed that was free of virus that was tested on arrival. And then here's the ARW is the Animal Resource Wing. That's the name of the facility. And this is the biosecurity plan we had for the people as they did their pig chores every day in those 3 rooms. They had first to go to the negative control room, the clean room. Then they had to go to the treatment room, which was eating the feed bin material, which we didn't know was positive or not for live virus. Then they had to go to finally the positive control room where we know we had actually poured the virus on the feed. So kind of low risk all the way up to high risk. And they had to change clothing, footwear, wear a mask, take a shower between each of these rooms. Very strict, because we don't want the people to move the virus between the rooms. Okay? So this is kind of how the treatment room looked. We had, there's the feed material up there in the corner from the positive bins. When mixed together, it had a CT of about 20, 21. And the little piglets, we kept them off feed for a night, and they were very hungry the next morning, and they just woofed down that contaminated feed. Okay? So we let them eat it naturally. And this is what we learned. So if you look at the timetable on those farm investigations, remember that was January 6, 7, and 8, till January 10, 11, 12. You know, that's the time we were on the farms. There's a timetable that we conducted this study of the bioassay. So January 17 through January 23. So a year ago, we were right in the middle of this process. And so this just shows you the treatment group, the positive control and the negative control, what happened each day. So each day we would look at the pigs to see if they were sick, and we would take rectal swabs of each pig to see if they started to shed PED in the manure. And so what you see in the treatment in the yellow column there is that after they consumed that bin material, about 4 days went by, but they soon began to shed. And there's a CT value of 34. That didn't work too good. But January 21, day 4, the first positive swab was 34, very weak. But the next swab we took that day was much stronger, 18.9. So virus was starting to replicate in the bodies of these pigs and be shed in the manure. And you can see that they also start to show us some clinical signs, vomiting and diarrhea. Now, at the end of the study, January 24th, we necropsied the pigs and we showed that there was a virus, PED virus, in their intestinal tract. Now, in the positive control group, you can see that after they ate the virus that had been spiked, they showed clinical signs and shedding very quickly. So we proved that virus in feed could cause an infection. And then negative control was negative. So our methods were clean. We weren't accidentally moving the virus between the rooms. Okay? These are the treatment pigs. These are the pigs that ate the bin material. You saw them wolfing it down, nice healthy little pink pigs, but a few days after they consumed that material, you see they were scouring, and their condition's not very good. And we looked at the intestinal tracts under the microscope, and we saw some interesting things. The slide up in the left corner there, that's normal small intestine, and you see all those long finger-like projections. Okay, those are the villi. Those are the absorptive structures of the intestine. Now what PED does is it kind of mows the lawn and chops all those down. And so right up there that's the positive pigs from the treatment group. And look how their villi, those little fingers, are just kind of very blunt. They're basically chopped off almost. And that picture on the bottom, the brown staining material, is PED virus in the villi cells themselves. So we showed that the virus had actually come into the intestinal tract, caused damage to the intestine, and actually was residing in the intestinal villi, in what we call the enterocytes. So we proved that the virus was there. So that was some interesting material a year ago. And we were very concerned that if we had made some mistakes and we didn't do a good enough job, that we would present false information. So we went back real hard and critiqued our processes. So I'm going to just take you through the critique that we put this study under. This shows you kind of how we think at Pipestone. So the first question we're asking, well, could the bin samples that you collected the bioassay material from, could they have been contaminated during collection? Could you take the paint roller as you climbed up the ladder? Would virus get on the paint roller just from the wind? And then you would take it and you would think you're pulling it from the bin, but actually you're contaminated on the way up or down. I think that's unlikely because it just shows you how we manage that. We always had the roller covered with a plastic bag when we were ascending and descending the ladder. And so the only time the bag was removed was when it went inside the bin and I was hanging down here, reaching and stretching for some of that feed material. And the bag was replaced on the way down. So I'm quite confident that we did not accidentally contaminate the roller. Well, maybe positive farms always have positive bins. Maybe it just blows around so much in the wind that every bin gets positive, and this was strictly an accidental finding. It had nothing to do with the feed, but it was due to the dust. Okay. So do positive farms always have positive bins? Not that we have detected. For example, the bins that I sampled in farm A, B, and C, the neighboring bin right next to those bins were negative. So we sampled multiple bins on the farms, only found virus in one bin. And we also went, and feed's not the only way this virus gets on farm. There have been several cases where we did not find virus in feed. We sampled all sorts of bins on positive farms, and they were all negative. I mean, we know, we went over the risk factors, right? Feed's not the only way this virus gets on a farm. In fact, Spencer Wayne, one of our veterinarians, actually tested a farm over a 10-day period of time as it was breaking with PED. Sampled multiple bins during that 10-day period of time, and none of the bins got infected, or contaminated, I should say. So it doesn't always happen. Does the sampling method produce false positive results? I mean, we had to invent this method. So what is it, what we call the specificity? Could it produce false positive results? Well, we went to negative farms and sampled bins, just to be sure that we weren't getting false positive results. And we found that no, if you got a negative farm, you're not going to find it in your bin. These samples will be negative. Now, was there room-to-room contamination during the bioassay? Now, I showed you the biosecurity protocol we practiced, but we also had one more bit of proof that this was not the case, because we were able to sequence the viruses. Remember that the positive control was a stock virus from Dr. Nelson's lab. That's got its own sequence. The viruses from the field, from the bin material, were different. We sequenced those viruses and saw that there were clear differences in the stock virus for the positive control and the feed bin samples. So they were different viruses. That was good to know. And can we replicate the bioassay? This was the first bioassay that had been done really in the world for PEDv in feed. The group in Canada was working on one too. Can we replicate it? We actually have. I'll show you some of the ways we've used it. We've replicated this bioassay, just the same methodology, multiple times. So I'm confident in the methods. Okay? You probably ask, why did I just waste 5 minutes of your time going over all those things? But if you remember a year ago, this is the kind of preparation you had to make before you were about to release this information to the swine industry. So we concluded that this is what we call proof of concept. The bioassay, proof of concept. It doesn't predict frequency of infection, doesn't give us any idea about how often it happens, for example. It doesn't give us any idea of the ranking of feed in the order of risk. But it does show that if the conditions are correct, and the virus is in the feed, and the pigs are allowed to consume the feed, they can get infected. We published that paper in August. And the day or so after it came out, I think I had 100 calls from CNN, Reuters, many pork industry publications, Washington, D.C. It was nuts. It was nuts. So I think after this, we wanted to show that feed is a risk. It's not the risk, it's one of the risks. It's real. I believe this is real. We've shown that contamination, and the Canadians have shown that potential ingredients may have be risky as well. So it could be an ingredient contamination, it could just be an environmental contamination, but the risk is there. And at the bottom there, we can't just focus on this. We have to remember that this is a comprehensive biosecurity plan for all the routes. So, once we did this work, I went to Casey Neal. Casey's our nutritionist. He came from PIC. He's been a great addition to Pipestone. I asked Casey, what are we going to do? And now we can't even go to Hawaii, right? So Casey had some ideas. So these are some things we did right away. Some things you probably have done. If you haven't, they're not hard to do. Some immediate actions that can be taken. As I mentioned, in the case of our sow herds we managed, we took all the animal byproducts out of those diets, including our growing gilt GDUs. Even milk replacer may have plasma. And so that was removed as well. So that was immediately done. Actually, Joel Niram had done that in 2013. We also went to the mills. You know, this was really neat. I'd never been in a feed mill very much. But we work with about 22, 25 different feed mills. We don't own our own feed mill. And so we said, we have to go talk to the people at the mill and explain what we learned and potentially try to help in a very collaborative manner. No finger pointing. People were nervous. So we wanted to kind of calm the waters. Let's look around that mill. Let's take samples with those rollers and try to find where there's some hot spots in the mill. Where might we find virus if we sample enough of these mills? And we did find some interesting spots where we would find virus in a number of the mills, not in every one. But in a number of the mills, we'd find the virus at the office, where a lot of people come up, obviously. In the animal byproducts that were sitting around in the mill. As I mentioned, we found it on trucks coming in. Driveway, entryway for the trucks. And then we also found it around the dump pits. So some of that earlier work we did, we validated with mill survey. So that was good. Because it kind of, again, it shows you where the bullets are coming from. Then we can take care of that. So we put in some things sanitation-wise at the mill. Cleaning some of these areas with some Synergize where we know there's a risk for virus. Using dry foot baths. There's a dry bleach product called Traffic Cop. Kills the virus in about a minute. That's a great dry foot bath where you can step into a bucket of this stuff and you don't have to deal with all the liquid. So dry foot baths are really easy to manage around some of these high-risk points. And then the trucks, it was really hard in our minds to kind of understand how we're going to wash a lot of these feed trucks. Some people are, but we concentrated more on the cab. And we put together some Synergize and sprays and wipes just to give the drivers some tools to clean their cab, their floor mats, their dashboards, wipe down the surfaces, their steering wheels. Of course, they're wearing their boots and things. So we tried to focus a bit on the cab, so where people's feet get put from the original work we did. Remember we showed you could get that virus right in your cab just by walking back in the vehicle. So very simple things like that were kind of our first wave of interventions. And we also worked real hard on behavior around the dump pit. We tried to stop the sweeping action of just sweeping debris from the floor into the dump pit. And some clever folks even made covers or made barriers just to kind of reduce the risk of accidental material falling down into the grain. So this was a key area of focus that didn't take, obviously, that doesn't cost a lot of money to put something like that together, but it's probably the link between how the virus got from the building down into the feed. Very simple. Okay? Now, we also set out on some studies to look at more long-term actions. And some of this is still in the experimental phase, but I'll share with you what we did. We looked at how can we treat the feed. Is there any way we can treat the feed if it's contaminated? If we've removed the animal byproducts, but it gets contaminated from the environment, can we treat that feed? We did a small study at our research group that just looked at pelleting time and temperature. We didn't have a pelleter, but we exposed feed to temperature and time that you may use to pellet sow diets based on some of the people I talked with. And what it showed is if you heat that feed up to 185 degrees Fahrenheit for a minute, you'll kill the virus in that feed. So I loaded up feed with virus. I put it under 185 degrees for a minute and I pulled it out, sampled. It's still PCR positive. There's still RNA there, but the virus is dead. Okay? So that pelleting is something that a number of groups have done to reduce this risk. Obviously, there's lots of equipment and logistics and things like that, but we do work with some systems on a research basis that pellet all their feed. And they think that's one of the reasons why they've stayed free. Now, the other way of treating feed is chemical. And I got this idea from Casey Neal. Because I said, Casey, is there anything we can put in the feed? Can we add something to the feed that might kill the virus? You know, what's out there on the market? And Casey found two products that I'll talk about a little bit, one more than the other, but one is called Salcurb, and one is called Terminate. And I'll explain to you what those are. Now, Salcurb is as both of these products are, they're liquid antimicrobials. They contain formaldehyde. In the case of Salcurb, it also contains propionic acid. Salcurb is a FDA-approved product for salmonella control in poultry and pigs. It's made by Kemin Industries in Des Moines. And you can see the label there, the description and approved use. It's labeled for salmonella. Keep feed salmonella negative for up to 21 days. That's what it's out there on the market, approved for. It's not approved for use with PED. And Kemin will be the first to say it's not on our label. So take it from there. I wanted to look at it because as veterinarians work with formaldehyde for tissues, formaldehyde actually desiccates tissue. So it binds to protein and desiccates, pulls a liquid out of a tissue. When we submit tissues to the diagnostic lab, we put them in formalin, and that allows the pathologist to kind of look at a dry section, preserves the tissue. So maybe it can bind to the viral protein and pull the liquid out of the virus and just dry it out. Now, I have to give a lot of credit to Kemin again. They have provided me with research funding, but that's where the money comes from. But Kemin is a very, very strict quality control company. They won't sell this to every mill. They know that in order to handle this product correctly, there's got to be a very high level of mill quality control. And so they'll go to a mill if is interested in putting Salcurb system in, and sometimes they won't sell it because the mill equipment or the way they do the business is not at a high enough level to deal with this obviously challenging product. This isn't something simple you just throw in the feed and forget about it. This is a product that's liquid, 6.5 pounds per ton. The mill needs to be OSHA approved, EPA approved. There's obviously some concerns potentially with worker safety, so it's got to be managed very well. This isn't something like you just throw some CTC in the diet. This is a whole different ball game. But I'll show you some data that suggests it might be something to consider because of its antiviral effect. But I want to recognize Kemin just for their quality control. Very strict, very strict. And they'll come and they'll train if the mill is qualified. They'll come and train the mill. They'll help get it EPA certified, OSHA certified. They'll help with all that process. There's extra equipment the mill has to buy to put the product in. So it's a very, very detailed process that might take 5 to 6 months. So again, this is not anything real simple. But when you see the data, it might be worth considering. All right, so I'm on my soapbox a little there. The main trial we did right away with Kemin, and we've published this one as well, was we wanted to see if we had virus-positive feed and we treated it with Salcurb, would that allow pigs to remain free? So if we treated feed, Salcurb, spiked it with virus, let the pigs eat it, would that prevent infection? Versus feed without Salcurb but spiked with virus. So this was called another bioassay, but an in vivo evaluation, so in living animals. So it's very simple. There's a hypothesis that it's a desiccant effect, and the bioassay we're going to run is very similar to the one I just told you about. So I'll put this table up of results, and I'll explain a little bit about the study design, and this will give you time to kind of peruse. So this was done again at South Dakota State. It involved 3 groups of pigs, 5 pigs in each group, just like we had before. The treatment, the Salcurb treatment, was pigs that were eating feed, coated with Salcurb, and then spiked with virus. So for 14 days, they were fed feed that was Salcurb treated but spiked with virus. Okay? So every time they went up to the feeder, they had the opportunity to ingest virus. The treatment, the positive control group was just like that. It was no Salcurb. So it's just feed spiked with virus fed to pigs. Very similar to what we did before, and there's our negative controls. And kind of what you're deducing from the trial there is we started in March, 14 days long, and the Salcurb, you see the PCR, that's the rectal swabs again, where every pig every day was rectal swabbed. And we obviously looked for clinical signs. Those pigs in the treatment group never got infected. They never got sick. Even though every time they went up to the feeder, they had the potential of ingesting PED. In contrast, the room of pigs that ate feed without the Salcurb, you see what happened there. They became infected very quickly. And then there's our negative controls. Okay? So a similar design, but really the first proof of concept again that perhaps this product has some antiviral properties. Here's our sal curb treatment group of pigs. Feeling pretty good. There's our positive control group of pigs that ate feed without sal curb. Not doing too well. And this was an interesting set of data as well. I also took feed samples from the bin itself, the feeder itself. And I used a grain probe model. I just didn't do a free catch. I actually made a little model of a grain probe and sampled in the hopper, the material hopper. And I tested it for PED. I wanted to see if the sal curb treated feed would have any type of action on the virus. Would it decay the virus? Would it break it down? So that what this shows you is on the x-axis we've got the 15 days of the study. On the y-axis is CT, so viral quantity. Remember, high CT means low virus. The green line right at 40 there, that's the negative control. So there was no virus in the feed. You can see it remained free of virus throughout the study. The red line is the positive control group. So it was spiked on purpose, started at a CT of about 25. That's not too good, but you kind of see how it starts there. Look how flat that line remained throughout the 14 days. Viral quantity remained very consistent over that 14-day period of time, right? The blue line is a sal curb treated feed. See, it started at 25, but quickly started ramping up and went very close to being negative. So it showed very quickly that the product was having an effect on the virus in the feed. It was breaking the virus down, and you were finding less and less of it each day that you took a sample. So this, to me, showed that this product does indeed have antiviral properties. So we concluded, again, and have published this, because we wanted Pipestone wanted the industry to know this. They wanted the industry to know about the transmission work we did. This is information the entire industry needs to know. This isn't going to be a secret. Everybody needs to know this, so they have the opportunity to make a decision. From this study, small as it is, just a few little pigs, clearly not a big farm study, but it showed some pretty interesting data. It showed that this product might have some effect. Now, since that time, we've done some more work with it, again funded by Kemin. I just want to share with you some of the big picture take-homes that we've learned about PED and feed, as well as the effect of sal curb. Let's go down the slide. We've done some work with PEDv survival. How long does it live in feed? We know if it's at room temperature, it'll be dead within a week. We know if it's frozen, it can live possibly forever, at least many months. But what about 4 degrees Celsius, which is about 40 degrees Fahrenheit? Kind of more refrigerator type temperature. No work had been done there. We showed that in complete feed, the virus can live at 40 degrees Fahrenheit for out to 21 days. So it's got very long-lasting capabilities in cool conditions. We're doing a study right now where we've actually taken the feed apart, and each ingredient in the feed has been spiked with virus, and we're studying it over time. So we're going to take the complete feed and break it down and see if there are specific ingredients that are higher risk than others. Because then we can target those ingredients rather than just have to target the whole ration. But that's not done yet, but just to let you know that's the next wave of work. From the sal curb point of view, we've done several studies to look at how long it lasts, how long it works, I should say. 21 days. Actually, it'll kill PEDv out to 21 days. After that, it kind of volatilizes and goes away. Just like the salmonella work. The salmonella claim, if you remember, showed salmonella-free feed for out to 21 days. So it's very similar to that label. We've tested it against many other viruses. It's very effective against other viruses, both what we call enveloped viruses, which are not very stable, and very stable viruses we call non-enveloped viruses that can live outside in the environment for long periods. So it works on other things. Casey Neal's done some real neat work recently where, in conjunction with the University of Illinois, He wanted to see if the cell curve treatment of the feed had any negative effect on the diet, digestibility, nutrient density. So they actually fed it to pigs and collected digesta, fecal material from the intestinal tract as well as from the pens of these pigs, and showed that measured treated feed and non-treated feed. Looked at energy, looked at the protein, looked at the cal-phos, looked at all the vitamins, amino acids. There was no negative effect of cell curve treating this on the feed as compared to the non-treated feed. So it doesn't have a negative effect on the diet per se, at least based on what Casey's done so far. We've run several trials, and others in the industry have as well. We don't see a negative effect on pig growth, pig performance, treated or not. No difference between gain and intake and conversion and those types of things. We're doing a dose titration right now to see how low we can take that original 6.5 pounds label dose. Can we take that lower? My guess is we won't be able to. And then we're also looking at, based on what we learned from the individual feed ingredients, will cell curve have a beneficial effect when we treat the feed ingredients? Will it neutralize the virus in specific ingredients? That's underway as well. Perfect. Last slide. So the risk of feed, I hope you take this home today, as a vehicle for PEDv infection has now been proven. This has been replicated by many other groups. Kansas State University, Suidae. We've done it several times too. So this has been replicated extensively. Control options we talked about, removal of certain byproducts, meal biosecurity, feed treatment could be an option, vehicle sanitation, all these things we just kind of went over associated with the movement of feed and the processing of feed. And I think in combination with some of the other topics we talked about in the very first slide or so, the feed-related awareness we have now and the new data we have, I think has really made a significant impact on the incidence of PEDv this winter.